Okay, guys, let's continue with rate of reactions. And in that lesson, we are going to highlight some factors that will affect my rate of reaction. Previously, we have to make sure that you know that collision theory, it's the main theory that explain why we have chemical reaction. In order to have a chemical reaction, we must have collisions. Not all of the collisions will make reaction and will cause reactants to make the products. We need a specific type of collisions. In order to have chemical reaction that produces a product, a collision between the molecules. Those molecules that they are colliding, they must possess and have minimum equal or more amount of energy, and that energy is called activation energy. Okay, so activation energy, it must be possessed and halved by my molecules that they are colliding. Also, the particles that they are colliding, they must collide in the correct orientation in order to have what? The obtained or the requested products. Okay, so let's move on to lesson number two. In lesson number two, we are going to highlight some things we can control in order to increase or decrease the rate of the reaction. Let me zoom in. How can I zoom it? Okay. Um, okay. The first reaction, or I'm sorry, the first factor, it's the effect of concentration. When we increase the concentration for reactants, we can see here from the figure, we will collect more volume as a product from a chemical reaction. It means we have more rate of reaction. So increasing the number of molecules per volume unit, it increase number of collisions, and those collisions, by increasing them and increasing the frequency of them, I'm increasing also in the same time the frequency of what? Of successful collisions that will lead to products. Okay, so in order to explain what's the effect of concentration, all the time increasing concentration will increase my rate of reaction, because we are increasing the number of molecules inside a constant volume, and we will increase in the same time the number of successful collisions that will lead to reaction. Okay, now we will go to the next factor. It's the effect of pressure, and that factor will study it on the gas phase. Okay, when we have reactants in the gaseous phase. Why? Because increasing or decreasing the pressure on the liquid or solid state, we will not move on the particles beside each other, or we will not make the particles move so much beside each other, because we don't have the compressibility characteristic in the liquid or in the solid state. So only in the gaseous state we can see the effect of increasing pressure. Increasing the pressure, I'm going to increase the number and the frequency of what? Of number of collisions. At the same time, I will increase the successful collisions. So we will have more collisions. So more collisions, more rate of reaction. Okay? Now, the surface area, this factor, we are going to talk about it when we are having a heterogeneous reaction. What's the meaning of heterogeneous reaction? It means the reactants, they are in different phases. It means we are going to react solid with a gas, or a solid with a solution. Different phases will give me a heterogeneous reaction. This heterogeneous reaction is shows it shows us the effect of surface area. It means having more surface area, more solid surface area. The gas or the solution particles will have more area to react, having more area to react. So the number of collisions and successful collisions also will increase. Okay, let's see that reaction. In that reaction, we have hydrogen peroxide. Hydrogen peroxide, we can catalyze its decomposition into H2O and oxygen using manganese oxide. The manganese oxide here is the catalyst. When we use the catalyst in the powdered form, we will see more catalyst effect. Okay, while when we use it in large particles, we will see the catalyst effect is less. Okay, so by increasing the surface area by converting that manganese oxide into the powdered form, I will increase the collisions, and so as well I'm going to increase what rate of reaction. Okay, so these are the three factors we can control in order to see different rate of reactions. Factor number one, it's concentration. By increasing concentration, I'm going to increase number of molecules inside the volume. So we will have more collisions and more successful collisions. All of these will increase the rate of the reaction. The pressure, increasing or decreasing pressure, we will see the effect of that on gaseous particles, not on solid or liquid particles, because we don't have the ability to move on or to be packed or away from each other's. But in the gaseous state, we have this characteristic or the ability. Okay, so increasing the pressure, we will see the same effect of increasing the concentration on a specific volume. The effect of surface area, it's more obvious when we are having heterogeneous reactions. It means we have different phases of reactants inside my reaction. So I'm going to see more gas or more liquid particles. They have more surface area to react with each other's. Um, Meaning of increasing surface area, I'm going to make the particles smaller in size. By this, I'm going to increase that surface area and I'm going to increase my rate of reaction. Thank you for listening, and we are going to the next lesson in the next video.